Hey Ray, this is Alex Merced from alexmercedcoder.com with another video on the C programming language. In this video what I want to go over is functions, pointers, and structs. Okay? And yeah, that's basically the goal in this video. So first let's go over how to build a function. So if you've done any kind of programming language before, JavaScript, C++, Python, Ruby, whatever, you probably have had to create functions, little bundles of code. Now again, C does not have object orientation. There's no objects, there's no classes. So there's no things you create that have functions on them. Structs will be the closest. Structs actually serve a lot of different roles in C because you don't have many tools to use to begin with. But the other big tool you have are functions, okay? And basically the way we create a function, you don't have to define a function within the main function, you can define it below. So let's do that. Why am I on only read-only mode? Well, let me refresh the page. Looks like it's a connection issue. Cool, there we go. So let's go below and let's just do a basic function. We'll just say this function is not going to return anything, so it's going to be called void myfunc because it's my function. Takes no arguments, and all it's really going to do is print f hello world. That's all it does. Okay, so this is the function definition. I'm saying the first thing I'm typing in here is what the function returns. The function gives back no particular values. It does things, but it doesn't give anything back. Okay, and there's no information that I'm going to need to pass into the function for it to do its thing. So it takes no information in and gives no information out. So you can think of this as like, this is what's supposed to come out at the end. This is what I need to put in the beginning, which is nothing, and then this is what it does in between, which is just print hello world. So once I define a function, I can invoke it, just like this. I can just say my func. And the cool thing about a function, let's see, why is it complaining? Implicit declaration of function, my func is invalid. Okay, I guess maybe it does want the definition to be above. Let's try that. There we go. Yep, that fixed it. Okay, so my func, and then I can just repeat it over and over again. That's a cool thing. You can use it multiple times. I don't have to type in printf hello world each time now. I can just do this, and now hello world will appear 3 times. Okay, let me just put a new line character. Always got to forget that C doesn't really kind of automatically do that. So there we go. Hello world, hello world, hello world. Okay, neat. Now, let's say we don't want to just print anything. We want you to pass in a string. Okay, so again, a string is an array of characters. So we'll say car, and then we'll just say my string. Okay, and I think that should type it for C. That should. So basically, this is a string of characters. That's what we're that's what I'm saying should go in. So to use this function, you need to pass in a string of characters, or an array of characters. Okay, and now we can then use that over here. Okay, and just say here, okay, %d, and then the new line character, and that's not %d, %s, and then we pass in my stir. Okay. And there we go. So now when I invoke the function, it wants me to give it an array of characters, aka a string. So first time we'll give it hello world. Second time we will give it my cheese. And the third time we'll just say na 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 na. So now when I run the functions, and that's what runs. Okay, so here I don't have to worry about all that. It just takes whatever string I pass in and prints it in there. Okay, so that's pretty cool. Okay, so that shows you how we can send stuff in, but again, this function still doesn't give us anything back. So what I could do instead of printing this, what I can do is we'll just give back the value, which really isn't super useful. You wouldn't do a function like this, but we'll just return my struct. Okay, but see, it's giving me an error because I said it returns nothing. I said void, meaning it doesn't return anything. So now I need to specify that it does return car. Problem is, this is an array of cars. Okay. So what I need to do is, I think I probably put an array here. No. Let's see here. Compatible pointer to integer conversion, returning car. Well, function. The result. Let's maybe not do that yet. Think about that for a second. Incompatible pointer to integer version. Why is it integer when returning car? Is this what it wants? Yep, that's what it wanted. Okay, so I'm returning an array of characters. Okay, so let's see here. Let's try that out. And the way this would work is we would have to pass this function, printf, wrap this inside printf. We'll just do the normal %s, new line. Okay, I'll explain what this is doing. Okay, I think I'm missing a parenthesis right here. There we go. So essentially, just like a normal printf, I'm saying, hey, I wanted to print a string here, the new line after it, except the string is being returned by this function. So this function runs, returns the string I pass into it, which is sort of like, adding extra steps, but the point is to show you that you can do it. It returns the string, and that's the string that's going to get interpolated right here in this spot. So if I run this, it prints hello world. It's a very roundabout way of doing it, but to show you that I can mark something as what's coming out. So what's going in, what's coming out of the function. Okay, cool. So now we know what a function is. Okay, sometimes you need clumps of data. Okay, and then that's where structs come in. Okay, so I might create a struct that's called dog. So struct dog. And then in here, what we do is we just define properties that a dog should have, such as car, or actually car, which is going to be name. And we'll say a name can be it's going to be an array of up to 10 spots. Again, you have to actually specify these things. Okay, and then we'll have then basically an integer, which is the age of the dog. Okay, and then I think a semicolon here. Yep, and there we go. We've defined a struct called dog. Okay. Interesting. Okay. Let me just get rid of this for a second. Now let's create a dog. So just creating a dog is like creating any variable. I have to specify the type being dog. I'm going to call the dog name Fluffy. Okay, and there's the declaration. Okay, must use struct tag to refer to type dog. Okay, I think I have to do this. Struct dog Fluffy. And now I can be like Fluffy dot name equals Fluffy. Okay, 6 letters, so that fits within the 10. And then put a semicolon. Now why doesn't it like that? Type car10 is not assignable. Car 10. Okay, just change this to a lowercase. I have a feeling that might play a role somewhere. 2, 2, 2, 2. Let me take a look at the docs here. So we declare books. Out there, int. So let's see where it assigns the book ID. Book ID is assigned, so we have to use a string copy function, which is going to belong to this string library. So we're going to copy that over. Okay, so let's go back up to the top here. Bring in the string library, and then we need to wrap this up in copy. Just take a look at the syntax for that function. String copy, the variable we're copying it to, and the string we're copying. Okay. Nope. Something else. Where did it go? Over here. So we're copying it to fluffy.name, and what we're copying is the word fluffy. Okay, and then semicolon. And why does it lie like that? Unless they defined it in here. I don't think they did. Nope. Print book. Yeah, no, that should be brought in by the include, so I will let that warning go. Okay, and then again, the fluffy dot age will equal, we'll say 5. Okay, and then we will first just print f the dog has a name of percentage string, which will be the string, and is of age percentage d, and then we pass in the data, which will be fluffy dot name and fluffy dot age, semicolon, and let's run it. Your command failed with exit code. In main C include string.h. I'm assuming it's an issue with just rep when bringing in this particular library, so I'm gonna have to let that go. Yep, nope, that's coming from that library, so I will let that go. But the point is, you can see that I can print the properties of all that fun stuff. So I'm going to get rid of this. We're just going to get rid of that property and just leave age just to get the point across. But you can have a combination of properties is the point. Okay. Now I may have a function to change Fluffy's age. Okay. So let's try to do that. Let's create a function that changes the age of a dog. So it would basically be void. We're not going to say void change dog age. And what it's going to do is take in a struct dog. We'll just call it dog. This is the parameter. So it takes in the struct of type dog, which is called dog. And all it does is going to say dog dot age plus plus. Okay, it's going to add 1 to the age. Okay, and then it will print the age. Print f percentage d slash n dog dot age. Okay, and we will use that function here. So change dog age, and we're going to pass in Fluffy. That's our struct of dog type. And then we're going to print Fluffy's age again, just to kind of show you a particular thing. Printf. Printf. Okay, this is going to be Fluffy.age. Now notice what happened here. We passed in Fluffy to the function, and it incremented the age by 1 to 6, but the minute it ran print again, Fluffy's age was back down to 5. Now, why is that? Okay, basically the natural behavior of a language. So this is going to be for any lower level language. So this is for C, Go, C++, Java. So the initial thing is that it doesn't pass in the actual dog. It's passing in a copy of the dog. So we're getting a copy of Fluffy, and we're adding 1 to the copy's age. So once we leave the function, the copy doesn't exist anymore. Fluffy's still age 5. But what if you actually want to alter the original Fluffy? You actually want this function to mutate Fluffy. Then you don't want to pass in. You don't want to pass in just the dog. What you do is you want to pass in what's called a pointer to the dog. Okay, which means you are passing in the memory address to where the dog is. Okay. So, and I think for that we're just going to be putting in an asterisk here. Okay. So what this means is that the parameter is the pointer to the dog. Okay. Okay. So that fixes it. We'll come back to that. Okay, let's go back to the documentation. But the idea is that the pointer will store the memory address, but there's so many different languages, it's hard to keep track of them all. Okay, so again, yeah, you declare them that way, that's all fine. And we're going to come back to assigning that in a moment. Okay, yeah, no, that's pretty much what I expected, so I don't know what is it complaining about. So let's go back over here. Dog.age. Okay, we'll figure it out in a second. But the idea is, now what I want to do is pass in the address of Fluffy. So I'd be passing in @ because that is the pointer address to the item Fluffy. So then the address of Fluffy becomes dog. Now let's see if it works. I have a feeling because of these 2 red squiggly lines, I probably have to change something. Let's see here. Use dog. Ah, I see what it's saying. It wants me to do this. Saying take the thing that's at that address and use its age property. There we go. That actually answers some questions about some other languages and the way they're designed. And see, now look what happened. Now it's 6 both times. Because what happened this time, we didn't pass in a copy of Fluffy, we passed in the address of where Fluffy exists in your computer's memory. So in this case, when I say, hey, add 1 to the age of the dog that was passed in, it's actually going to your computer's memory, finding Fluffy, and aging the dog. So it ages it inside the function and outside the function. That's the difference between, it's what's referred to as passing by reference. You're passing the data by, not by passing the data in, by passing a reference to the data, which means the things that happen in the function persist. Now this is important because in other languages like JavaScript, Python, and Ruby, this decision's made for you. Okay, so when you pass in things like in like JavaScript, objects or arrays, they're always automatically under the hood being passed as pointers, which means anything that happens in the function alters the data. In languages like Go, Java, C, C++, you get to choose when to use pointers. Okay, which means so basically you get to choose when are you passing in a copy of the data versus a reference to the original global version of the data. So that's the beauty of pointers. So we've learned structs. Structs is basically there are no objects, there are no hash maps, there are none of these other data structures. There's just structs. So if you want to create some sort of combination of values with names, then structs are the only game in town. Okay. There are no classes, so you can't do methods. So all you can really do is create structs and create functions that you can pass structs into, and that's kind of how you would sort of end up in the same place. So instead of creating a method of dog for dogs, I would create a function called bark, and I'd pass in the individual dog into that function, and the dog would bark. And you can end up in the same place. You can pretty much simulate object-oriented programming with functions. It's just that classes are just set up in a way that just semantically is easier for a lot of people when they're thinking of their class, or they're thinking of their programs in that object-oriented manner. Okay, so that's why some people still prefer to just use C over C++ because they didn't need the classes. You could theoretically do a lot of the same things in a purely functional way. Cool. So my name is Alex Merced from alexmercedcoder.com. There is more to C. Okay, there's plenty of tutorials out there that they can get you deeper into C. But these are the main features and the features that I wanted to cover. So with this, you can start doing some cool stuff in C. There are other libraries, as you see here. There are other libraries you can download in the C that you can do all sorts of cool stuff with. Go explore, go have fun. Now you understand the language better, and more importantly, since a lot of the other languages are built with C and C++, hopefully this gives you a better understanding of how other languages work. Because under the hood, they're using this to build out those compilers, those interpreters. And I think this kind of oftentimes answers a lot of questions. So my name is Alex Merced from alexmercedcoder.com. I'll see you guys later on.